right, a couple more practice problems. Let's see how we do on these. Now, this one you'll notice is not approaching infinity, but is still an improper integral because if we were to substitute in one over for x dividing by 0, that would be undefined. And then if you just were to do the integral of this would be the natural log um, of x going from 0 to 10, and the natural log of 0 is still undefined. So this needs to be done the same way as every other problem we've done, because the dividing by 0 is a problem. It is, so therefore this makes it improper once again. So what we're going to do is go ahead and change it into a limit. And the question here is, as k approaches 0 is not really what we need. When you think about what we're saying here, is we're talking about the graph of 1 over x going from 0 to 10. I want this area under the curve. But the idea here is I don't really include 0. I'm doing all my values as I approach 0 from the right hand side, from the positive side. So really here, what I need is the limit as k approaches 0 from the right hand side. And that understanding right there, understanding our interval going from 0 to 10 includes 0, but only from the right hand side, left hand side doesn't matter, is what makes this problem possible to be done. So, and it may not be, it may be divergent. It may not converge. It may diverge, but it still can be done. So here we go. So we're going to do the limit as we approach k to 10 of 1 over x dx. So now we're ready to integrate, and the integral of this would be what? We leave the limit alone. The limit as k approaches, that didn't go as planned, k approaches 0 from the right hand side of the natural log of x approaching k to 10. So we're going to go ahead and say, all right, I substituted my 10, natural log of 10. Now, why am I not writing limit here? Well, because there's no k's. This only matters is for the k approaching 0 from the right hand side, so I don't need it. So minus, now over here I'm going to need it though, because when I write the limit of my natural log approaching k, now here's the key, I have a k, so I need that. So now for the next step, the natural log of 10, I don't even need absolute values anymore because 10 is a positive number, minus the natural log of, now, and when I go ahead and evaluate here, what we're saying, we're approaching 0 from the right hand side. What we're really saying is it is a positive little number. And we need to remember what that means for natural logs. And when you look at your natural log graph, a little positive number results in you should remember this from your previous algebra course, results in the graph going negative and down. There's a vertical asymptote here at 0, so it's just going towards negative infinity. So therefore, this is the natural log of 10 minus a negative infinity, which therefore means we have natural log of 10 plus infinity, which again really doesn't matter. All we really care about here is we're approaching infinity and the graph diverges. Okay, let's take a look at number 6. Number 6. Okay, this problem, is it improper? Why, yes it is. We're approaching infinity. So here we go with our little dance. We're going to go ahead and say we want the limit as k approaches infinity of the integral from 1 to k of 1, and I'll go ahead and rewrite this as a negative exponent. This is x to the negative 1.5 dx. Okay, so now we can go ahead and integrate that. This is amazing. The integral of this would, well, we leave the limit as k approaches infinity. So now we're going to end up with what? X to the negative 0.5 divided by negative 0.5, evaluated from 1 to k. And we can go ahead and rewrite that. So let's see. This is the limit as k approaches infinity. I'm going to drop my x to the negative 0.5 down to the denominator, and I'll rewrite my negative up in the numerator. So it's negative 0.5 times x to the 0.5 evaluated from 1 to k. And why is this amazing? Well, we've seen similar problems like this before where we said it was not converging, it was diverging. And you'll notice here, you'll notice this is a different result. This is not what we've seen in the past. So what we'll do, we'll go ahead in here and substitute in. So we got the limit as k approaches infinity of -1 of 0.5 times k to the 0.5 minus a -1 over 0.5 times 1 to the 0.5. And if you remember, 0.5 is the same thing as square root, right? So if it helps you, we'll go ahead and rewrite this as square roots. It's 1/2, right? K, or 0.5. So this would be -1 over 0.5 times the square root of, and actually, well, let's go ahead and evaluate this limit while we're at it. We're approaching infinity, so k is going to be something really, really big. Okay, so that way I don't have to write that again. Minus, well, minus and minus makes it plus, 1 over, the square root of 1 is 1, so it's over 0.5. And we can go ahead and simplify this, because 1 divided by 0.5 is the same thing as 1 divided by 1/2, which is the same thing as 2. Right? So we're going to go ahead and rewrite that. That is 2. I'll rewrite this 1/2 up to the same idea. This is just going to be -2 divided by the square root of something really, really big. And even though it's a square root of something big, it's still going to be something big, right? Think about how square root functions work. When I substitute in 4, I get out 2. When I substitute in 9, I get out 3. When I substitute in, as my numbers get bigger, my outputs get bigger. So this is going to end up being -2 divided by something really, really big plus 2. Well, and as that gets big, this is going to approach 0. So therefore, my answer, quite simply, is 2. And that's the amazing thing about this. That's what makes this so cool, is in previous problems, we've said it's diverged. Here, it looks very similar to problems we've done, but now it is converging. And the key to that is the degree of the exponent. We don't cover that in this class, but there are some rules where you say if that degree of the exponent is above a certain number or below a certain number, you're going to get convergence versus divergence. But that's really a calculus 230 type concept, calculus 2 type concept. So nonetheless, I hope that helped, and more practice problems to come in the next video.